All right, so now I want to graph y is equal to x squared minus 3, and then we'll compare it to the parent graph as well. I already started my table. Now here's what we can do. Here's what this equation tells you to do. Whatever your input or x is, square it first, and then subtract 3. So negative 3 squared is 9, positive 9, and then minus 3 is 6. Negative 2 squared is 4, minus 3 is 1. Negative 1 squared is 1, minus 3 is negative 2. 0 squared is 0, minus 3 is negative 3. 1 squared is 1, minus 3 is negative 2. 2 squared is 4, minus 3 is 1. And then 3 squared is 9, minus 3 is 6. So we can graph all those points. Again, I can go by ones, so I'm not going to write anything down on my axes. If nothing's written down, that means you're going by ones. But negative 3, 6 is right here. Negative 2, 1. 1, negative 1, negative 2. 0, negative 3. 1, negative 2, 2, 1, and then 3, 6. So the graph is still a parabola. Would look, whoops, like this. Sorry, that was a really bad drawing, but it will look like that. It should just be a line. Trying to trace it out a little bit better. That's a graph of y equals x squared minus 3, or y equals x squared. If you remember the numbers, 0, 0, 1, 1, 2, 4, 3, 9. It would look like this. And it's still a parabola. So the graph for y equals x squared, just going to write the arrows right by it, would look like this: y equals x squared minus 3. They're the exact same shape. To get from the red graph to the blue graph, it's a translation down 3 spaces. And I know I didn't write it, but I still want to figure out all the other parts as far as for the blue graph. Whoops, wrong way, sorry. But the graph opens up. The vertex is right here at 0, negative 3. Sorry, I'm going to scoot it down so you could see it. And then lastly, the axis of symmetry, again for the blue graph and the red graph as well, is x is equal to 0, or the y-axis. And for this next example, now I want to graph y equals 2x squared minus 4, and as always, compare it to the parent graph. So in this case, this is in the form of y equals ax squared plus c. A is 2. We kind of already talked about exactly what A does, and then C is negative 4. So I've already created my table, but here's the order that we need to do things in. Whatever your input is, square it first. I'm just using my order of operations. There's no parentheses, so exponents come first. Then multiply by 2. And then lastly, subtract 4. So here's the first thing that we do, here's the second thing, and then here's the third thing, because we have to follow the order of operations. And that's what I'm going to do for every single input. Square x first, negative 3 squared, right here, 9, then times 2. 9 times 2 is 18. 18 minus 4 is 14. Now I input negative 2. Square negative 2 first. Negative 2 squared is 4, then times 2. 4 times 2 is 8. And lastly, 8 minus 4 is 4. Negative 1 squared is positive 1. So we square that first. Then 1 times 2 is 2. 2 minus 4 is negative 2. 0 squared is 0. Times 2 is 0. Minus 4 is negative 4. 1 squared is 1. We should get the exact same y value for x when x is 1 as we did when x is negative 1. So it should be negative 2. But 1 squared is 1. Times 2 is 2. Minus 4 is negative 2. 2 squared is 4. Times 2 is 8. Minus 4 is 4. And then 3 squared is 9. Times 2 is 18. Minus 4 is 14. Now we can graph each of those points. I actually could fit everything on here by going by ones. Negative 3, 14, here's 10. So 11, 12, 13, 14 will actually be right here. Negative 2, 4 is right here. Negative 1, negative 2 is right here. 0, negative 4, 1, negative 2, 2, 4, and then lastly 3, and then positive 14. As always, the graph is still a parabola. Should have arrows at each end, and then the graph looks like that. For y is equal to x squared, we have 0, 0, 1, 1, 2, 4, and then lastly 3, 9. Oops, should be right here, and negative 3, 9. So now we're comparing the blue graph and then the red graph. So what happens with the blue graph? First of all, it's translated now, specifically 4 spaces or 4 units. There's actually a vertical stretch because of A by a factor of 2. The vertex, again, we're taking a look at the blue graph. Sorry, I'm going to zoom out so we can see everything here. The vertex should be right here at 0, negative 4. And then the axis of symmetry is still x is equal to 0 or the y-axis. Those are all the different parts of that graph.